Our second presentation will be how to work effectively as a cross-platform developer. Graham is a research software engineer in Oxford University. Having grown to love Objective-C in his undergraduate NeXTSTEP computing lab, he has spent more of his career writing Mac and iOS software, but has always had a soft spot for Linux too, and for Amiga. Graham, please tell us what Amiga is. Today he will talk to us about... No, go ahead.
Oh yeah, so the Amiga was a computer from Commodore in the 80s and the 90s. It was, I think, not particularly well sold in Canada, so maybe your sort of Canadian users wouldn't have come across as many as people in Europe, particularly Germany.
It did well in Canada.
Oh, okay.
It had a following. Yeah.
Nice.
There you go. So, Graham, feel free to take over. Let me stop my share. You start sharing, and if you want to start your camera as well, I'll mute myself.
Sure. So I will press that button, and then hopefully you can see something that looks... yeah, you can see my screen, and if I press that button, you can see my slides. So because of the way that I've had to set this up, I can no longer see Zoom. So if you type a question into the chat and I ignore it, it's not because I'm ignoring you, it's because I didn't know that you did that. So, as we did with Marius's presentation, it's best to just ask questions over the microphone at the end of the talk. So what I've learned during Marius's presentation, apart from a lot about being an indie developer, because I've spent most of my career as an employee, is that we have to start with a cat picture. So this is Leonidas, King of the Spartans, who is my my roommate. Luckily, kind of files himself away quite neatly most of the time, so it doesn't take up a whole lot of space in my house. So what I want to talk about is the way that I specifically work as a cross-platform developer. This is definitely the things that have worked for me, and some people will see things that they recognize or that you want to adopt yourself. Some people will see things that where the way that you would go about something is quite different from the way that I've done it. And that is very welcome. That's a good topic of conversation at the end, because I'm still trying to sort of improve as a programmer and as a software engineer, and to adopt practices that other people have that will improve the way that I do things. So if there's somewhere where you think, a better way to do that is is this other thing, please do chime in. So as in that brilliant introduction I was given, I kind of got into computing professionally through the Next platform and NeXTSTEP. So when I was an undergraduate, we had a computing lab full of Next computers. Actually, the undergraduate computing was all in Pascal, and I had an Amiga in my room in my sort of student accommodation, and I would get the computing practical early, build a solution in sort of an hour or so on my Amiga, and print out the listing on my high quality dot matrix printer that I had, and go in the morning to the computing lab, type it out on the Next, demonstrate to the sort of practical instructor that I had solved the problem. So then, half an hour into the day, I was done, and I could use the rest of the day to learn about Objective-C and AppKit and all of the things on the Next platform, which I really enjoyed working with. And then that got me a job, literally in that room, managing that network of Next computers. But even at the time, Next had already been bought by Apple at this point. So there was questions about, do we migrate to Mac OS 10. And Next was a workstation company. They didn't have any sort of back end like server products. So, I was maintaining a sort of heterogeneous network. We had all sorts of different operating systems, like definitely all Unix operating systems. I've never been particularly comfortable with Windows. I've used a lot of different Windows versions from 3 to 10. Um, Actually, like if you want to order them numerically, then from 3 to 2000. But if you order them chronologically, then from 3 to 10. Uh, and I've just never been a particularly expert Windows user or particularly interested in it. I've had this sort of like Unix background, and particularly through the Next, that's really informed the way that I sort of treat computers. So back in this sort of time, the state of the art, particularly on Unix for doing cross-platform software, was this thing called GNU Auto Tools. So there's AutoConf, AutoMake, and they have a thing called Auto Project, which kind of ties all of that together. Now, if you've ever downloaded like a piece of open source Unix software from like the internet, from GitHub or wherever, and the build instructions are /configure, then make install. Then that's the kind of thing that that is using these GNU Auto tools. They are famously hard to learn and understand, and everybody just finds something that works from some other project, copies and pastes it into their own project, and then tweaks it until things start compiling. Typically, they do that on their own platform, which is usually Linux, and then assume that their software works on like FreeBSD or on Herd or on Solaris or wherever, and that is not always the case. This was an era when other tools were being explored, and I remember, I don't remember who said this, but I do remember in the sort of introductions that everybody gave at the beginning, someone said that they were interested in like cross-platform sort of build tools, and from that era, the one that is still popular now, that is still a good way for people to build their projects on one platform that will then work and compile on a bunch of other platforms, is CMake, particularly for like C or C++ projects. But it can integrate with like any compiler you want. So if you're using Go or Rust or anything, then that is a common choice there. But back in the day, none of these sort of alternatives like CMake or Jam or a bunch of other tools, Google's JIP, none of them were particularly well adopted. So there wasn't like a clear winner. So there was like this big mess of different ways that people would build software, with the most common one being the GNU tools. So anyway, the Next platform kind of got replaced by Mac OS 10 because Apple bought Next and then used the NeXTSTEP operating system and the Cocoa APIs and the Objective-C language as the sort of core of their new product line. And so I mostly followed that. Like I definitely used still, particularly other Unix platforms. But I was mostly a Mac person. That was where I was most comfortable, and that was where I had the most experience. And that kind of defined a lot of my early career. So I moved out of Unix systems administration into doing Objective-C development for a telecoms company, then software security, like a sort of antivirus, endpoint security product, and then basically was doing Mac software until the iPhone happened. But I kind of maintained my love for the Amiga, and this is just a little pitch in the middle of my presentation. I Twitch stream with a friend on Thursdays at 1800 UTC. I don't know what that is in all of your time zones, but a couple of hours a week where we pair program remotely on an Amiga and we write Amiga software. So if that's the kind of thing that interests you, check out dosamigas.tv. If you're here for the sort of cross-platform development content, then like stick around, because we're done with the pitching something random now. So, like, what I've kind of told you is that I have this sort of heritage, this basis of my experience and education in programming that comes very much from the Unix world and very much within Unix from the Next and Apple sort of camp in Unix. But even when I've been like mostly a Mac person, using a Mac, developing software that I'm going to use on a Mac and that other people are going to use on a Mac, that doesn't mean that all of the tools that I've used have been the things that Apple supplies. When Mac OS 10 was new, Apple were very keen in showing how well Java worked on the platform, and even James Gosling, who was the creator of Java, used a PowerBook laptop as his like main computer, and did like sort of interviews for O'Reilly where he said like here's why the best Java development environment is a Mac. Similarly with David Heinemeier Hansen and Rails, a lot of the Rails community used Mac laptops and what was then a proprietary text editor called TextMate. It's now free software GPL editor. And so this was really why you saw like a load of Apple badges whenever you went to a developer conference. It was because people who were writing cross-platform software, whether they were writing Ruby on Rails or Java backend software or Swing applications for the front end, all of these people had sort of adopted the Mac. Notice that like all of these are sort of back-end and scripting technologies. I mean, my story goes back sort of to like 2000 roughly. So we are well before smartphones, and the move from like being a Mac person to being a Mac person who writes iPhone software for people happens sort of halfway through my story. But I'm kind of telling you all about one platform at the moment. I'm telling you all about my experience with the Mac and with Objective-C, and that doesn't fit the sort of the topic of my talk, which is about cross-platform development. So what happened? Well, honestly and fairly personally, what happened was a period of burnout, sort of in the middle of my career. So we're going back to like 2013, 2014. I sort of got very deeply cynical about about the work I was doing, about the like the companies I was doing in, and particularly about Apple. And this kind of manifested as like seeing decisions that that Apple, this like remote company that like worked on a completely different continent from me, seeing decisions they had made in the way that they ran their business and taking them incredibly personally, and then sort of taking it out on like that development community and on that sort of way of working. So let me give you an example. One of the things that interested me a lot about Mac OS 10 at the beginning of like the 21st century was that they were very much promoting the fact that it was an open source friendly platform. The core Unix layer was all free software. We're using their own APSL public source license. They had a lot of you saw the logos for like Perl and Python on the previous slide. Guido van Rossum, the creator of Python, and some like important people in the Perl community all had talks at Apple's developer conference about how Python is a great tool on a Mac, or like Perl is great for a Mac, and Apple sponsored bridging technologies so that you could write native apps in Ruby or Python or Java, and ship these as part of the platform. And then sort of once they got big enough and successful enough that they no longer needed to depend on other people's software, replaced it with their own stuff. And I kind of felt like this was a sort of bait and switch. It said, come here, it's open, we work with all of this free software. And then had kind of completely closed that off, or the way that they introduced the App Store rules, which was the guidelines, which was I think something that was only sort of tangentially Marius like touched on in his talk, but the idea that I could spend a few weeks or a couple of months developing an app, only for Apple to say no, we don't want to sell that, and there is literally no other way to get it out to customers. I kind of took that more personally than it was fair to do at this time. And the biggest problem with that from a sort of professional point of view, apart from the fact that I burned a bunch of bridges in the community and sort of lost a lot of commitment to my work and to what I was doing, was that this happened at the time that Apple announced the Swift programming language. So I was then sort of disconnected from everything that Apple was doing at a time when they introduced an entirely new language and then like a new UI framework, and the community really sort of rallied around Objective C is old and busted now, the new hotness is Swift, and I had completely ignored them during that time, and I had completely avoided this whole new way of working, and honestly never felt like I sort of caught up again since that. But what it did do, what I got out of it was that it encouraged me to look at what I was doing and to look at the way that people who are like Apple platform developers, people who are writing software for the Mac, iPhone, Apple Watch, Apple TV, look at the way that they're doing it, look at the way that everybody else is doing it, and then say, okay, so what can I learn from over there, or where can I deploy this software that would have some different people who'd be interested in using it, or some different customers for the way that this works, or where are other platforms that would benefit from learning about the way that people who are like Mac developers do it. And I tried a lot of different ways to cope with doing all of this thing cross-platform. So, I have had each of these computers is something that I have owned in my goal of kind of getting away from being like an entirely mono-platform developer. So we've got like a fairly beefy Dell gaming laptop up there, which runs Windows, it runs Linux perfectly fine as well, or the Intel NUC, which is a little called the next unit of computing. It's basically just a little box that slots on the back of a monitor and gives you a Windows PC. I will let you into a secret, and this is perhaps one of the most contentious points that I'll make in my talk. I really like the Metro style UI in Windows 8. It was a really interesting way to present data on the screen and to try and get out of this idea that everything is about the apps and the way that the developer packages the software and sell it to you. That there are sort of data feeds of what your friends are up to, or your photos, and that these are all being delivered from different places. I appreciate that it would have been very hard for Microsoft to make that stick, because they had so many customers who were already invested in the way that Windows desktops already worked. But I had both a Windows Phone and the Surface RT, which was their really low end ARM tablet, and I thought it was a nice way of working. The Pinebook there is a sort of $100 ARM laptop that just runs ARM Linux. And I tried to build a workflow where I could use any of these and switch, and have all of my tools and all of my files available. And what I did was I ran a NeXtCloud instance on a server. Now, NeXtCloud, at its core, is a sort of a free software version of Dropbox that you can run on a server and access your files by using its web client or native clients. But it also has these sort of plugins, which it of course calls apps, because that's what everybody calls them now, where you can have a password manager built in, so you can have your passwords everywhere, or you can have a calendar built in, so your calendars are shared everywhere, or your task management or whatever it is that you want to do. And it is certainly possible to set up a situation where you can like log into a Windows 10 computer or to a Mac or to a Linux PC, and you can have all of your files and all of your like work available. Or you have all of your files available on like an iPhone or an Android phone, for example. But what I found was that this was a very inefficient way of working. It made me sort of have multiple nearly but not quite the same ways of working on a bunch of different computers, and to sort of forget things like where the nuances were in what did or didn't work in particular contexts. So what really worked for me, which is like the thrust of the rest of this presentation, is and I've represented it as Apple Plus here. What I'm really saying is this: pick your home system. Like just pick the computer that you are comfortable with using, and design your entire workflow around sitting in that. Make sure that your day to day is in the place where you are most comfortable, because that's the thing that's going to make you the most productive. And I'm not even necessarily talking about developer tools at this point. Like even things like knowing how your calendar works and is accessed, knowing how to check and reply to like emails or instant messages from clients or colleagues. Being able to take notes while you're watching a video, these are really, really basic. We're talking like using a computer now, or if you are like Marius, an indie, and you have to do everything from like writing the software to washing the bottles, then knowing your spreadsheet software so that you can do your accounting and your taxes efficiently. This is all like a key part of making sure that your computer doesn't get in the way while you're trying to do your work. But recognize that if you're a cross-platform developer, then you are building software that is going to be deployed away from your Mac or your Windows PC or whatever your preferred version of home computing is, and use those other platforms where you need to use them to get your work done, which is typically like testing, packaging, and deployment. And this is something that came up in the sort of pre-talk introductions as well, was this question of how do I deploy to other platforms, but when I'm a cross-platform programmer. For the most part, you probably need to use the native packaging tools of the target environment, like particularly if you're going to use if you're developing for like the Mac or for Windows. There are ways to build Windows packages on non-Windows systems. There's a thing called NSIS, which is the Nullsoft installer system, and it kind of works. But you're going to want to test that the package that you built actually functions correctly, which means you're going to want to use a Windows computer, or if you're building for multiple Linux, then you can build like a .deb, so a Debian package, and use a converter tool to convert it into an RPM, which is a Red Hat package. That will, it will work, but is the package it creates exactly correct? Well, you're going to have to like boot into a Red Hat system and install it to work out what happens. So, my point is you are not going to succeed at cross-platform development by only ever using a single platform. But you are going to be much more efficient if you use that platform as much as possible and only go out to the other ones where your workflow deliberately requires it. So another example, so we talked about cross-compiling earlier. Cross-compiling is great for efficiency because if you have got some like non-portable code or like non-portable use of APIs or something in your program, then you have a script on your development machine that builds for your platform and for all of the other platforms you target, you can find out like compiler warnings and errors in that cross-platform step much quicker than if you like pushed your code. If you waited until you pushed your code up to GitHub or whatever code host you use, and then run a CI job to find those things. And I've worked on teams where that is the way that cross-platform development worked. Particularly, I worked on a team in ARM that was building software for supercomputers, and obviously you can't just give every developer a supercomputer under their desk. That is incredibly expensive. So we had a CI where, like, once we'd built and tested stuff on our Linux laptops, we'd push up and then build for like the Cray systems or for the IBM Blue Gene systems, or or whatever the target was. But that meant it could potentially be hours before we found out about a compiler error in code that we introduced. And that slow feedback cycle has knock-on effects that really slow down your development, because by the time you find out that there was a problem in that code you committed, you've already moved on to a different task. So now you have to stop that second task, which slows that down, and go back and like learn what you're doing in your first task and try and fix that, which slows down fixing the first task. And so you're in this kind of time shifted multitasking state where you can't really focus on anything you're doing, because you're going to get reports that something you did a few hours earlier wasn't right, and that really gets in your way. So use things like cross-compiling as much as you can in order to improve the rate of feedback of your cross-platform workflow, but do not think that that's going to get you out of using multiple platforms. So because I'm on a Mac, I get to just kind of show my dock as a way to act as a proxy for, here are the things I do that are that are single or cross-platform. And you can see that like a lot of the tools I use are the native tools. So like the Apple Calendar, the Apple Mail, the apps from Omni Group. So the fourth arrow down is OmniFocus, which is a task management, a sort of GTD tool, and Omni Outliner, which is a tool for writing like outlines of documents and things. The Flower is the TextMate app, and of course I've got the Xcode developer tool installed. Often, if I'm prototyping a UI for somebody, I will do it in like the native tools using Xcode, because I know that I can do that very quickly, and all I need to do is say, like, are these buttons and controls the things that you need, and like, does this workflow work well? And then I can go and like throw that away and re-implement it in Electron or whatever it is that we're going to use. And I'll come on to choosing the tools on the next slide. I've also kind of pointed to the Evernote app in this in this image, and that's an interesting one because I use it very much as a native tool. I appreciate that it is cross-platform, and I can get my notes on the web or on well, Linux is hard because like there isn't an official client, but there is an open source client, or on Windows. I don't do that, however. I use it as like a Mac application for writing notes, or like occasionally kind of open it up on my iPhone and edit some notes. But like I'm kind of using it as an app that is part of my native macOS desktop workflow. And while I'm not saying you have to do that specifically, I am saying that the best way to work effectively is to take your notes in something that is comfortable for you on your on your primary setup, with what I'm calling your sort of home OS. Now I take exactly the opposite position on developer tools, because I think that the apps that you are working on are things that are there for your customer, unless you like like Marius, you're an indie developer, and then you're building for the to sell the application that you want to sell to the people you want to sell it to. That's entirely fine, and you can choose whatever you want in that context. However, if what you're doing is like agency development, or you're working for an employer and your business are the people who are going to be using this software or selling it to other businesses or to like end customers. Your job is to solve their problems, not to impose your choice of technology onto them. So I always take a very flexible approach to choosing development technologies, and I build in whatever is going to be useful for the customer. So now we see that like the arrows have kind of all clustered around the end of the alphabet. For some reason, IDEs seem to all have names that start with letters near the end of the alphabet. So we've got Visual Studio, Visual Studio Code, Xcode. Visual Studio is there because one of my clients has asked me to develop a desktop app, a mobile companion app to their desktop software. And their desktop software is a Windows application written in C# with Windows Forms. So I have chosen to use Xamarin Forms, which means like learning how to use that tool. It means learning how to program in C#. It means like learning how C# programmers work. Because when I hand over that project at the end of my engagement, they're going to have something that's better for them because they understand that technology and they can share code between their projects, or they can maintain both of them. If I had said, okay, I'm going to do this in SwiftUI because like I love SwiftUI, then they would have had something that they didn't understand how to maintain and that only solved a portion of the problem for them. So there is an amount of flexibility, and there's an amount of like learning on the job when you do this, because it means kind of keeping an open mind about a range of different development tools and picking the one that is suited to the project you're working on. As I've said before, things like cross-platform build environments, cross-compiling tools help you build locally and test remotely. And this is the bit where I kind of have to say, for very weak reasons, why in practice the Mac is the best choice for this kind of way of working. And it's not a reason I particularly feel like happy defending, really, but it's that if what you need to build is mobile applications, well, you can run the iPhone simulator on a Mac and you can't run it anywhere else. But you can run the Android emulator anywhere, including on a Mac. So you can test both things on the same computer without having to break out to somewhere else. Now, I appreciate that what you could do is you could have your code on a shared, so that it's accessible through maybe you have a Mac Mini in the corner of your office that you access through VNC, so you can log in there, check out the code, build, and test on the simulator, or do all of your packaging in Xcode, or your iTunes store, App Store, connect stuff that way. That is certainly possible. And if the savings that you would get from working on Windows or Linux or some other platform would outweigh the cost of every time you need to test on iOS, you have to go and remote desktop into this dusty Mac in the corner, then by all means do that. It is a super weak reason for suggesting that the Mac is the best way to do this. But remember that what I'm saying is you want to sort of speed up the turnaround time of finding out where you are in your development work, which means speeding up the time it takes you to go and validate that your thing still works on Android, or still works on iPad, or still works on desktop Linux, wherever your target is. Another part of this cost trade-off is that, whoops, I pressed the wrong side of the button there, so we now get to go through all of these transitions again. Another side of this cost trade-off is that the supposedly cross-platform tools very frequently aren't fully cross-platform. So I mentioned at the moment I'm writing an app in Xamarin Forms. I've actually had to learn the sort of C# way of working and the Xamarin APIs, but then I've also had to write bridging code in native iOS. So it happens to be like C#, but using the UIKit APIs to do a couple of the features on this app. One related to maps and one related to photos. And I would have to do that again on Android using again C#, but the native APIs. And if we were to also target the universal Windows platform, then I would have to learn that as well. So a cross-platform tool typically doesn't stop you having to learn some of the details of the native platform, of each of the native platforms that you're working on, and their APIs, and their like frameworks and their object life cycles, and the ways that they deal with like touch events or event loops or anything like that. You at some point you're going to reach the limit of the built-in tool, and you're going to have to reach out to something else. Now, the extent to which you do that depends to some extent on the extent to which the community around that cross-platform tool has already encountered and like solved, either in the tool itself or in like third-party components, those problems. So you would find that if I built this app in like React Native, for example, I might have had different experiences around maps and photos than I did in Xamarin. Or if I'd used Flutter, my experience might have been different again. And so that's something to build into your assessment of which of these tools you pick. But remember that one option, and we'll come on to thinking about this option later in the presentation, but one option you've got is just to write different code bases for the different platforms, or maybe write your core logic in something that you can easily compile for every platform, say C++, and then build like separate sort of wrappers around that in the different native APIs. That has trade-offs that we'll come on to. A great thing to do is to pick a design language and sort of design like paradigm toolkits. So I'm not talking about like particular software or tools at the moment or environments. I'm talking about thought processes and paradigms, like the ways in which you think about your application, and apply that to different technologies. People get really offended when I say that, because they say, but React Native works so much better if you use Redux and Sagas, or they say if you're going to be building JavaScript front ends, then you should really be using Elm, and you should be using like the functional style that it promotes and whatever. The fact is that like the most efficient way for you to build your software well is for you to understand the design of your software well. The different communities all have these different preferences for whether you use like objects or functions, and whether you use like MVC or MVVM or Viper or whatever this week's acronym is, or whether you like have side effects, or whether you trigger sagas which then run your side effects asynchronously, and all this kind of stuff. And the fact that it is so community focused kind of leads to like a sort of weak evidence that it's a subjective thinking, that like you can obviously build successful software in each of these ways. Now, the less you follow the sort of the like tool native thought processes, the less likely like community help from Stack Overflow or from subreddits or forums or wherever you're looking is going to directly apply to what you're doing. But also, the less work you're going to have to do designing multiple applications for the multiple like target environments. The reason I'm suggesting this is that because I work on multiple projects, I work with multiple technologies. It's better for me to pick a way to design software that I understand and I know works. And you can get a long way with using like MVC, which people understand for like back-end applications, people understand for front-end web applications, people understand for desktop and mobile applications. The XUnit style of unit test framework, which exists on pretty much any programming language you're ever going to come across, and SQLite as a data store. Like that thing, it may not be the best everywhere, but it works everywhere, and it's a great starting point everywhere. And if if you find that it is constraining you or leading you to build inefficient software down the line, then of course you can integrate other thought processes. But the fact that you didn't have to think about that before you started writing your code meant that you got to have discussions with your customers about how well the app is working for them, about whether the design you've come up with is working for them, and you've got value to the customer earlier, and you've got to iterate on it earlier, and that is really powerful and really useful. Again, I am not saying use MVC and XUnit and SQLite. I'm saying use the design language and the sort of high-level software design that you're comfortable with, and take that with you as you sort of travel around these different frameworks and these different tools. So the kind of the other part is doing as much testing as you can on the computer that you're using, so that you don't need to wait for a CI job to run on a remote host, or you don't have to switch. And so here I'm saying don't use dual boot, use virtual machines, because that gives you a faster turnaround time. If you dual boot from your development system into your test system, and then you find a bug, you're going to be very inclined to just kind of fix it in that system, and then you're going to be back in the position of having a cross-platform workflow that doesn't quite work well enough for you everywhere that you need to use it. Now, if you're building browser-based software, then of course, on most systems, you have access to most of the popular browsers. So you can get Edge for the Mac, you can get Chrome for the Mac, you can get Firefox for the Mac, you can get those for all of the computers. Safari, of course, is a different story. And with Docker and other virtualization technologies, Docker is brilliant because you can run your back-end software on Linux, where I'm using sort of scare quote fingers, but on whatever your development system is. And even what the screenshot is showing Firefox for Linux running on a Mac. So I can use Docker to test my native applications locally without having to boot into a different operating system, without even having to have a separate window for VirtualBox. Remember also that everything you're doing is not just for you; it is for the people that you're working with, including your team. Does your client even care whether you are building for a particular technology or a particular framework? In the example of the Xamarin application that I've been talking about, yes, they do, because they're going to be maintaining this project going forwards, and they've got C# experience. It made sense for me to take the hit of learning the C# rather than make them take the hit of learning whatever other technology I could have chosen. But maybe maybe they say, oh, we need to to target sort of 50% of people on mobile phones. You can just go, okay, well, here's an Android app written in Kotlin using the native Android tools. It ticks that box, and they don't need to know. They don't need a cross-platform thing. Maybe they don't even need to know that. Maybe someone says, okay, I need an app that runs on iPhones, and you give them something that's written in React Native. It doesn't matter that it is written in a cross-platform tool. It matters that it runs everywhere that their customers need it to run. So think about whether you even need to have the conversation about technology with your clients, and if you do, what constraints that imposes, and whether it makes sense for you or for them to sort of compromise on your ideals, as it were. And then where are your the rest of your team? Where are their skills and where are their interests? Something that I go forwards and back on is whether it's best to write one cross-platform app for all of the platforms that you're targeting, or whether it's best to build one app for each of those platforms? And the answer is it kind of depends on on what you're capable of doing and on everybody else is going to be along for the journey. I think I probably could write a native iOS app incredibly much faster than I could do it in like React Native or Flutter or any of these cross-platform tools. But I would be very slow and bad at writing a native Android app. And so that means that if I have to target both, I could write an iOS app quickly and an Android app really slowly, or I could write one like React Native, for example, app fairly slowly. Well, that second one is actually the winner because I'm going to my aggregate time on that one project is less than my aggregate time on both the iOS and the Android project. I might give my clients a false sense of progress by going, look, I've done the iOS thing and we're on the second sprint, and then spending months and months and months to get anywhere on the Android side of things. So that's basically all that I had. So thank you very much. I will now stop sharing my screen so that I can sort of engage with the Zoom again, see the chat, and we can ask questions and that kind of thing. My contact details are there. Please feel welcome to reach out and get in touch with me. So yeah, thank you.
Great presentation, Graham. Very interesting. And I know since I started working on mobile, there's lots of technologies that want to create software for different platforms. I am yet to see one that everybody says, this is it. Always the community is divided, either this, either that, or it's better to develop native. Maybe just, as you said, some things work better for certain clients. And it's also important what you do with your product after you build it, right? Who's gonna continue to manage it, or maybe it's just one-time product and doesn't matter, or people have to work for it for next decade maybe. So it's important to use some technologies that other people can also build upon. So let's see if there are any questions. Feel free to unmute yourself and ask. Maybe I will ask a question.
Sure.
Graham, if you look in the next 10 years, what do you think will be the technology that will have maybe the most traction in building cross-platform apps from whatever you see from today?
That is a really big question. I think, and I might lose friends by saying this. I'm not saying this because I want to. I'm saying it because it's true. I think that JavaScript isn't going anywhere. And particularly TypeScript is building a lot of traction as the particular way to use JavaScript for a lot of people, and that is going to be a big thing. I think also an interesting. We're talking now over a decade, and so a lot of platforms are going to move towards being ARM based. We know that Apple are coming out with their ARM Macs on this week sometime, like Tuesday or Wednesday, and we know that Windows already works on ARM, and that the mobile platforms are ARM, and that the Raspberry Pi is getting popular, and this new Pi 400 is is really interesting people in sort of use as a sort of coding environment. Now that could close some of the historical gaps you've got where you've built your thing. It used to be like you built your thing on Windows, and you go to a Mac and the CPU is different, and nothing works at all. But now all of that is kind of coalescing around the ARM platform. Maybe that's going to make some things easier. So ARM and JavaScript are probably two big things to pay attention to.
Thank you. Any other questions?
Hi there, Graham. Question
Hey.
for you. You take the approach where you try to decide the platform or technology you're going to use based on the particular client's needs, and you're going to take the hit, as you say, of ramping up your own skill base if necessary in that specific technology, right? I'm just curious, is this because you're bringing a specific set of domain knowledge that positions you as, I want this guy, even if he has to learn a whole new technology, I want this guy to do this development for me? Because I've never had that position. I'm kind of like, I'm in this lane. If you want somebody in that lane, get somebody else.
Sure. Okay. Yeah, that is a great question. So thank you. And to some extent, yes. So my current job is in a university, and so like I'm on this like software engineering team for hire within the university. There is literally no chance that I am going to be the domain expert in whatever the client comes to me with, because they have a PhD in that, in that field, and I have never heard of it until like they come to me. So part of it is, what software can I find that already exists, that already addresses this problem, that I am allowed for either because it's open source or because we can get a license for it, that is going to help me to to get this thing done. So the another example of a project I've worked on recently was one for doing slide viewing for histology, which is like tissue samples in in sort of medical cases, and the images are in this like weird, what they call a pyramid format, where there's like a small thumbnail, and then there's a few tiles at a bigger zoom level, then like a lot of tiles at a bigger zoom level, and then a ton of tiles at a bigger zoom level. And it turns out that there is already an open source JavaScript library for dealing with that format of image. So makes sense for me to like learn Electron and build them an Electron app for doing their thing, rather than try and work out how to replicate all of that behavior in like Cocoa or in .NET or whatever else I might have used. So in that case, my domain knowledge is really not like knowledge of the problem that people are solving, but knowledge of the way that you talk to academics in order to understand their problem. And so the sort of technology side is like a sort of second order problem. I think that like this is something that is if what you're doing, I don't know like how you work, but if you're like a consultant or a contract developer for working as a sort of agency basis, then you have the choice between picking like a way of working or a field of working that you market yourself as the expert in, and then like making the technology match a problem, or picking a technology that you're an expert in, and then not taking long to ramp up when you join some team, except that they then have to train you in what the problem is. And both of those have have similar costs and similar benefits. Great.
Thank you. If there are not other questions, thank you very much, Graham, for the presentation.
Thank you.
We'd like to try something different. I don't know if anybody is interested, but do you have any questions about something else related to software that you might like our participants to answer? Feel free to ask. We'll just wait for 1 minute. Let's see. Maybe some advice for your career or something like that.
D here again. It's a comment I had though in response to the first presentation. And I just wanted to add, in addition to that was a lot of great information, but encourage people to file your taxes and probably hire somebody to look into it, because even though you may not be having a lot of revenue at the start of putting out software, you will have invariably a ton of expenses that you can use to reduce your taxable income, but you need to track it properly and probably get a tax specialist to help you with that. But it's almost always definitely worth the effort of getting someone to help you with that. That's my tip.
Definitely.
I just wanted to add, based on what Dee said, that's something that I also learned fairly quickly, and so now I'm using an accountant to help me with the taxes. It's very helpful, even if it seems easy. They know a lot of tips on how to reduce your expenses there. Another topic, I saw a question in the chat from Erica. She asked if I outsource my design or if I design my apps myself, and so if so, what tools do I use for design? So as Graham also said, if you use Xcode for coding, I think it's pretty easy to prototype an app and design. That's even more true with SwiftUI now, which makes designing super easy. I haven't outsourced design so far. I just bought some icon packs once and for art, and so I use Xcode, and for some art-related products, I use Adobe Illustrator and Procreate, and that's all.
Okay, thank you. Joseph has a question. Do you want to ask it?
Thank you, Drago. This is for not only the speakers, but also the general audience. I'm a retired engineer and project manager, but what I have noticed is there's a new trend coming, which is called citizen developer, which is basically there's a huge requirement of many developers out there. And there's a new trend of having people programming using no code or low code platforms. Some of that stuff is migrating from, I think there's over 800 programming languages out there. And there's a big fight, as I've heard from the different speakers here, about, what tools to pick, what platform to pick and stuff like that. But there's a general trend now moving towards a different level playing field for development software across the world. And I just want to hear any other comments, whether people think there will be a trend that will be established, or is there something new twists and turns? And because this is really an evolution of how we've gone from languages to mathematics to programming. So we just want to see your comments or your thoughts on this.
Okay, well, I like the sound of my own voice, so I can chip in here. Yeah, I think like the sort of citizen developer idea is a really important one, because something that we've lost over the last few decades is the idea that a computer is something that I bought and therefore I own and I control, right? We've gone from it boots into a basic, and so I have to know how it works in order to get anything done, which is like, that's a really bad experience. I'm not saying that that's the best way a computer can be. But we've gone to this, it is an appliance that you are licensed to use by this vendor, and that they will tell you what applications are acceptable to use. And so any tool, whether it's like a graphical drag and drop thing like Scratch or some of these visual programming environments that you're talking about, or whether it's just like an easy to learn automation tool like AppleScript on the Mac, or something like that. Anything that gives that power back to the owner of the computer is something that I'm very interested in. And the limitation so far has been the sort of the commercial support for these things, because it's kind of needed the vendors to to build like an ecosystem in order for the things to be seen as valuable, in order for like these environments to be perceived as realistic places to develop software. Now, programmers don't help them, don't help this thing by like laughing at visual programming environments and by saying, well, like if you're not typing 80-column text into a green and black Unix terminal, then you're not really a programmer, which I fundamentally disagree with. But there is now, along with this, this understanding of the need for computer literacy, there is also a lot of interesting grassroots movements in social programming, whether it's things like a code club where you're teaching programming to to sort of teenage or young children, or whether it's things there are a lot of like cooperative development houses in Britain now where there are like software teams that are entirely employee owned and are building software for the social good. And that kind of movement, pinned with this understanding of the need for computer literacy, can take this out of the problem where you need some trillion-dollar company like Apple or Google to realize that there's benefit in something before it gets adopted. That's not a straightforward answer to your question. It's not this is the thing that's going to like win or make this thing successful, but it does point to a trend that if there's enough momentum behind it, enough of a backswell, then maybe we can just make this thing happen ourselves.
Thank you.